students. Um, this is, I think, all students here are coming from undergraduate programs. Is there any student from master degree or doctoral degree? Oh, he's the one. No, Faris is actually from master degree. He's the only one that's coming from master degree. Yeah. So welcome and also thank you that you can spare your time to attend these seminars, and hopefully you will get something from the seminars. I think this is very I think this is very relevant for you, particularly for the one that thinking about what will be my title for my final assignments or final tasks. So yeah, what Chahinaz and Jessica will explain today is very relevant to our field, particularly in environmental infrastructure engineering. This is about nature-based solutions. Yeah, more about nature-based solution. Maybe some of the students they don't have like maybe a proper definition what is that nature-based solution, but I think some of them already heard about nature-based solution. So maybe you can explain to them later that what is nature-based solutions. But I think this practice actually we have done this one from our ancestor. The nature-based solution is actually something that we have done before, but unfortunately that more and more days we start to live this good practice. I mean, like previously we solve everything. We depends on the natures, and we also try to do like what natures do to solve our problem. But nowadays, sometimes because our rapid developments, then we propose the other solution. But unfortunately, this is not sustainable solution. So that's why now, Jessica and Chahinaz try to do a research on nature-based solutions and also try to make a nature-based solution more structured so it will start so we can start to use it again as a sustainable solution for our development nowadays. Yeah. Okay, I think that's all from me. So we have like use I'm expecting like around 70 students to attend this workshop, but yeah, I think it's not 70, but yes, at least some students attend because of the other things they have to leave and then cannot attend the seminars. So our seminars later on it will moderated by Pak Kurniawan, and each presenters it will be like 45 minutes, yeah, and we will give you sign if it's near your times, and then after that we can continue with discussions. Hopefully some students can ask. Jadi kalau if you can say it in English, it's okay. You can say it in Bahasa, and we will try our best to translate what is your questions. Yeah, I mean, like feel free to give a questions. Don't think about English. The most important in the seminar that you absorb and gain more knowledge, and then after that you can do something with what we have talked here, what we will talk here today. Yeah. Okay, I think that's all from me. So I will just give to Pak Kurniawan. He will be moderating this session. Then after that, Chahinas and also Jessica will present their presentations. Okay, thank you.
Okay, good morning, ladies and gentlemen, colleges and students. On behalf of Department of Civil and Environmental Engineering, Faculty of Engineering, Universitas Gadjah Mada, I would like to formally welcome our guests from Faculty of Spatial Development and Infrastructure System, Institute of for Natural Resources Technology and Management, TH Köln, Germany, to our department. We are delighted to have you here at our campus for this general lecture. We will discuss about a vital topic about how to keep our water system safe and strong through nature-based solution as our city continue to grow so rapidly. My name is Kurniawan Putra Santoso, and I have the honor to moderating this session on behalf of Department of Civil and Environmental Engineering. Okay, before we begin our main presentation, we will hear some opening remarks that have been delivered by Bu Leni as the head of Environmental Infrastructure Engineering study program. And now we will move to the main session of our event. We have two great presentations today that connect perfectly with each other. First, please welcome Chahinaz Ziani. She is an associate researcher at TH Köln University of Applied Sciences in Germany since 2024, and she is also a PhD student at Helmholtz Center for Environmental Research. Before this, she worked as an engineer in Morocco for the companies Regoner and Hydroprotect. Today, she will talk about practical tools at the interface between integrated water resource management or IWRM and urban planning. Her presentation will help us understand the big picture of how water management and city planning must work together. And the second session will be presented by Xhesika Hoxha. She is a research associate at TH Köln University, University of Applied Sciences from since 2021. She will focus on our region with her topic co-designing nature-based solution for Southeast Asia. And she will show practical examples like rain gardens and green roofs, I think, and explain how to choose the best option for our local area. And the next session, we will have discussion or Q&A with Chahinaz and also Xhesika. All right, let's get started in the first session. Please welcome our first speaker, Chahinaz. Her presentation will take about 45 minutes. Chahinaz, the floor is yours.
Good morning, everyone. Do you hear me well? Good. So, good morning. My name is Chahinaz Ziani. It is my great pleasure to be here today with you to give this presentation. I hope that you will get some useful information from what I will present today. And it's again a great pleasure to be among students here at UGM at the Department of Environment. So I will thank you so much, Mr. Moderator. So I already also prepared a slide, but you already said everything. So I am currently a research associate at TH Köln, but at the same time I'm doing my PhD in hydrology and combined with water quality. At the same time, so I also have an engineering background in hydraulics, environment, and urban planning. And my first working experience back in Morocco was mainly related to environmental projects. So, so the title of our presentation today is Practical Tools Linking IWRM, Integrated Water Resources Management, with urban planning. So when we hear the term of IWRM, and I would say, did you ever, or I would ask the first question, did you ever heard the term of Integrated Water Resources Management? So just yes, no. Ever heard about Integrated Water Resources Management? So yeah, maybe you were voting. So anyone who heard about before, just like raise your hand if you heard about Integrated Water Resources Management. If not, then also again raise your hand. I will not ask questions. Just raise your hand, but it's fine. So when we hear the term of integrated water resources management, so generally what we mean by that, So we have here two parts. So water resources management, managing the water resources, and integrated. And by integrated, we mean across sectoral process. So we involve different stakeholders to promote for the coordination and the development of the water resources, the land resources, and anything related and the related resources in order to first maximize the economic benefit, achieve the social welfare, but also without compromising the sustainability of the vital ecosystems. So we have here three pillars. We have the social equity, we have the economic efficiency, and we have the environmental sustainability. And when we talk about urbanization and IWRM, so we generally, when we are in an urban area, we have several challenges. Generally, we have increased water demand due to overpopulation, we have increased impervious surfaces, we have increased water losses, and we have a water degradation of the degradation of the water quality. So how can we overcome these challenges to attend the IWRM? So of course, the first step that we should take into account is that we need to know our system. We need to assess it well, okay? So because we cannot manage what we cannot quantify. So I need to know it. I need to know how much water I have, how much water did I lose, how much each sector of the sectors I have, how much water do they use as well. So we cannot manage what we cannot quantify, and therefore the water accounting or the water budgeting is the foundation for an integrated water resources management success in our cities. And therefore, so our lecture today, it's going to be mainly, first I will start general by talking a little bit about the hydrological cycle. I think all of us know what is hydrological cycle, but if not, we will do a quick reminder, and then we will talk about the water balance in different system. We talk also about the water accounting, because there is a difference between water balance and water accounting. And finally, we will also present briefly some tools of the water accounting. And with that, I would also to take the opportunity to present one of the tools that we developed within the framework of the polyurban water projects. So without further ado, let me start with the hydrological cycle. Again, just yes or no, do you know the hydrological cycle? Yes, amazing. So generally, the hydrological cycle is just the natural flow of the water and the continuous flow of the water from one location to another location, or from one state to another state. Okay, so it generally starts with the solar radiation. Okay, what did I do? Okay, so it generally starts with the solar radiation, right? That create some heat energy and let the water, due to convection, to evaporate and then go to the atmosphere. And if we have the suitable conditions, then it will fall again as a precipitation. This precipitation that falls into land, before even reaching the land, can be intercepted by the vegetation. This is what we call interception, or can infiltrate in the soil, and then evaporate again through evaporation, or it can also evaporate through transpiration, through vegetation, or it can also be flown as transformed into surface flow, or deep percolation and go into the groundwater. Okay, so this is the main movements of water for the hydrological cycle. And when we hear the water balance, so it's a balance, right? So the water balance is the equation that will permit us to quantify how much input do I have in my system, so how much water I receive to my city, to my agricultural land, to my catchments or watershed, and how much water is it out, okay? And for that, we need to define what do we consider as in and what do we consider as out. So let us quickly, or let us all of us read the definition of the water balance. So it's the equation that describes the water flow into and out of a hydro system and quantify the rate of change in the water being stored within it. Of course, we have some quantity coming in, we have some quantity coming out, and then we have something that stayed stored in the system. This is what we call the change in storage. So this is the general equation, and for that, I will just like collective answer. So the first part will be related. My voice is heard, yeah. So, or I can have Thank you. So the first part is related to the inflow, and this second part of the equation is related to the outflow. And let's now brainstorm to define what could be the inflow and what could be the outflow. So does anyone have an idea about what is P? Precipitation, yes. Very good. And E? This is an input, so it's coming. So it's an inflow. Yeah, very good. So it's an inflow. It's come from outside. Okay, so this is precipitation plus external inflow. Now we go to the outflow. So ET, what could be? Very good. Q. Yeah, I heard it. Discharge. Very good. And then we have the delta SGW. This is, if we both summarize them, this delta SGW, what can be? I talked about it just before. So we have in, we have out, and we have something that stayed in the system. This is what we call the storage. Okay? So the storage can be in the soil, can be in the groundwater, or can be in the water bodies. Okay? And these are the general terms. So precipitation, inflow, evapotranspiration, outflow, and the change in the storage and the different storage, soil, groundwater, and in the water bodies. Of course, we have different systems. Every time we are assessing the water balance, we can assess it either in the irrigation scale, we can assess it in the urban scale in a city, or we can assess it on a catchment, on a watershed scale, or even we have studies that try to assess it on a global scale. And now again, I would like your some answers. Let's start with the agricultural system. And for that, so based on this picture, what are the inflows here in my system? What can be? Yeah, very good. And infiltration, it's always something that comes from precipitation and the water infiltrates. Okay, so this is an output. Okay, so what is, if you notice, so everything, so this is my system. Okay, so this is my system. So this is the delta S. Okay, so everything that is with this sign coming in to my system is an inflow. Everything that is going out of my system is an outflow. And if we notice, we have two arrows that are coming in. Okay, we have precipitation and we have capillary rise. Does anyone have an idea about what is capillary rise? So simply the capillary rise is the movement of water that is against gravity, and I can show it to you by a very simple exercise. So if we have like a bucket of water, right, and we have a ball, right, and we try to put the ball inside the water bucket, you will always notice that like there is a force that is like pushing the ball to the surface. Okay, and this is exactly what happens also in my storage or here in my system, and this is the capillary rise. Okay, so here again, the system is like P plus capillary rise, it's ET plus Q plus delta S plus deep percolation. Deep percolation is the water that infiltrates into the groundwater, so deeper layers of groundwater. And the catchment area, so the same, we have P is as an input, and outputs we have the AT and the Q, and of course the delta S in the different systems. And now in the most complicated system, I would say, which is the urban system, and here I have also many inputs and many outputs. So the inputs are precipitation and then imported waters, because sometimes the water that I have in my system is not enough for water supply. Okay, so I need to bring water from outside of my city to make sure that I have enough water for my population of different uses. And then you have groundwater inflow, also if we pump the groundwater. And then for other outflow, we have evaporation, soil infiltration, runoff. Here, this is very specific for the context of the city. We have the wastewater, and finally the changes in the storage. Okay, so this might seem very complicated, but generally we can simplify the equation into P, it's equal to runoff plus evapotranspiration plus or minus the delta S, or the change in storage. And generally, when we talk about long time scale, okay, when we have like 30 years long of assessment or more, or we are in steady state systems, which means that mature catchments and catchments with no big influence or human influence, we generally get the delta S more or less equal to 0. Okay, so this is mainly for the cases where we have like a very long assessment of 30 years or something. And then if we have like mainly catchments that with less human interventions, so we can notice that we have the delta S more or less 0. And I would like to show you some of the cases. I would really like to show you that this water balance can change from one place to another. And for that, I would like to start with the Yogyakarta, right? And so I used, to be honest, one tool that I wanted to show to you, if I can. So one link, it's called the Esri water balance application. So this is one tool that I wanted also to present here. And it's a website, online website, that can provide you with simple water balance. Okay, so if we so based on it, so you just, when you enter that website, you just type your location, okay, and directly it will direct you to your study area. In this case, we have Yogyakarta, and it gives you all the components of the water balance. Okay, so time series of the water balance of minimum 20 years. Okay, here also we have it from 2000 to 2025, and with all the elements. So precipitation, how many precipitation fall in this year, runoff, evapotranspiration, and then changes in the storage. And then we wanted to assess and see for the long period of 25 years, how much do we have. So in average, we had around 2008 millimeters of precipitation. 1,100 millimeters go to evapotranspiration, and 900 millimeters go as a runoff. Okay, so this is in general. Same thing, we did it for another location in Köln in Germany. So here also it's a little bit different. We have in precipitation less. Remember, we have 2,000 in Yogyakarta, now we have only 930. Evapotranspiration goes only 170. Remember, in Yogyakarta we had 1,000. And Q goes around 750 millimeters. And finally, the last study case is Cairo in Egypt. And now we see that like almost nothing in terms of precipitation. So the whole year, it's an average of 74, evapotranspiration 42, and discharge 33. And now I would like to ask a question. So these are the values of the 3 case studies. And which city has the most precipitation? Jogja. So Yogyakarta has the most precipitation. And do you have an idea why? So why in some areas do we have a lot of precipitation, and why in some areas we don't have precipitation? What is the main driver? It starts with C. Exactly? Yeah, it's climate. Okay, so we in here in Jakarta we have tropical climate, and the tropical climate generally is characterized by a huge amount of precipitation yearly. Okay, but we also notice that we have also differences in how this precipitation and evapotranspiration, how this precipitation is divided into evapotranspiration or discharge. Okay, if we see the study case of Cologne, they also have some precipitation, so it's almost 1,000. But we noticed that, like, for example, in Jakarta, most of the precipitation was did go as evapotranspiration, right? But in the case of Cologne, most of the precipitation is transformed into runoff. Do you have an explanation why it could be behind this? We can give you a hint, okay? So in Germany, it's very cold, okay? So what happened? Remember when we started the hydrological cycle, the first thing that we said is that the hydrological cycle generally starts by that, like the energy, the solar energy that creates the heat, that let the water evaporate. Okay? In Germany, generally, we don't have much energy as we have it here. Okay? And that's why we have huge amount of energy that is linearly translated into evapotranspiration, also with the huge amount of vegetation that leads to a huge amount of evapotranspiration compared to the case of Germany. And also, this is also explained the same thing why most of the P becomes also Q in the case of Cologne. So these are examples of the water balance tools. Okay, so with these tools, you can assess the water balance. I showed you the example of the water balance application by Esri, right? So this is an application online, open, everyone can use it. And you just type your study case and it will give you time series of the different components of the water balance. And then you can do the assessment, generate these graphs that we did here for the study cases. But this is generally the Esri Water app can only give you like a general idea about the water balance in your study area. And unfortunately, it does not take into account the small scale. Okay, so when we talk about urban area or small agricultural area, it doesn't also take into account the human influences like irrigation. So it has its own limitation. Okay, and that's why when we would like to go deeper, or when we would like to go into small scales, we have also other available tools like this one. So side scale urban water mass balance assessment. It's a very also it's open source and you can just like directly download it, and it's an Excel sheet, and this Excel sheet quantifies also the water flow throughout, in and out and through the urban site, and it is very useful, especially for the neighborhood scale. So it gives you all the components starting from assessing precipitation, evapotranspiration, that's one. And then you do go to assessing the water resources, right? In terms of if it's like water supplied by a centralized network, or they use other alternatives such as rainwater harvesting. And then you get your final graph. So at the end, you get also a graph that is similar to this one, but with the numbers that are specific to your neighborhood or to your urban area. So we have other tool. It's called Urban Water Balance Model. It can be a little bit complicated because it's mainly on Python, so the programming language Python. But it started also with a Excel sheet, and now it's on Python. It's the same principle. And yeah, so this is the more or less the schematic logic behind the tool. So yeah, so these are the main tools that I wanted to share with you. Of course, if we had more time, I would gladly go into a demonstration of each tool, how we can use it, and we can do exercises, but unfortunately we don't have much time. But I would invite you to go through these websites and then use them, because they are very handy, and for each one of the tools you always have a manual that can go to you by step-by-step guideline on how to use it. And now we would like to go to the second concept, which is the water accounting, another term that is also useful for the water budgeting, but it's really good to make the difference between the water accounting and the water balance. Can someone tell me, or just brainstorming and tell me what can be the difference between the water balance and the water accounting? I mean, it's fine. What do you think can be difference between the water accounting and the water balance? And if we already have the water balance, why we do need another complicated term and use the water accounting? Yes, please.
But for water accounting, it actually accounts for the availability of clean water.
Yeah, that's part of it. It's very, 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 very right. Okay, so exactly, I would not. Do you have an answer? No? No. Okay, sorry. I thought you raised your hand. Okay, then, so simply the water accounting is a more complicated system that does not only take into account how much inflow, how much outflow I do have in my system, but also puts much higher intention into the availability of the water, but in each sector. Okay, I can know how much I have used for the water supply. I know how much I use for the irrigation. I know how much I use for the industry, for the commercial. So in each sector, I know. So it's going to more detailed water balance. We can say, this is a conclusion of today, that the water balance is a step of the water accounting. You cannot do water accounting if you do not start with the water balance. Okay? And here, exactly this slide says that, and it says that managing water is getting more complex. This is the reality. Humans are altering the basin hydrology, so we are no longer in the nature hydrology of the catchments, and the complexity, it's getting higher and higher. And I took this graph for me, it's very illustrating the situation. So this is the natural hydrology, and this is for the Jordan Basin, okay? And in the 1950s, so it started we have some human influence. We started to build some dams and everything, and it's getting more and more complex. Okay, so the water balance is no longer enough to assess or to quantify. We again come back to our first sentence, to quantify our system. And that's why we go to do the water accounting. And that's why the water accounting is a systematic acquisition, analysis and communication of data and information related to stocks and fluxes of water in natural, distributed, or heavily changed systems within a geographical domain such as irrigation system, river basin, or a country. Here again, the scale, we can do water accounting for the different scales. We can do it for agricultural plot. We can do it for the river basin. We can do it for a whole country. So generally with the water accounting, we answer the following questions. How much water is used? So it's not longer how much water do we have, but how much water is used, where, how much water remains, how much I do have, where, in which sector do I have more water, and in which sector I have less water. Where do we have water deficit and where we have more water? And of course, we have several definitions of the water accounting, but they all go into the same direction. And if we start a little bit of history, so this term started in the 1950s, and several frameworks of the water accounting has been developed in the 1950s, but they are, of course, getting more and more developed. And This graph shows the development of the different water accounting framework. And of course, we have two types of accounting, either flow accounting or depletion accounting. Generally, the flow accounting, they account mainly for surface water, and the depletion accounting, they account mainly for the subsurface water or the water in the soil. Okay, and of course, these are examples of frameworks that were developed. Some of the frameworks were further developed every time they release new version, and to develop more comprehensive water accounting schemes. For example, everything, as I said, that is blue, it's flow accounting. Everything that is green, it's depletion accounting. But when we see this mix, it means that like this framework contains or take into account both types of accounting, and of course with different scales, agricultural systems, administrative, and also river basin system. Okay, but here comes the question: with all these types of accounting, which one should I use, or which one should I choose? I mean, just okay, I have all these frameworks, but which one should I use? What is the first criteria of choosing which type of accounting to do? It depends, of course, on what are my needs. Okay, where am I working? What do I need? What kind of information do I need? And based on that, if I am working on agricultural system, then automatically I will look to the ones that are related to the agricultural system. If I am trying to develop a policy, something regulation, everything, I will go to the ones that are related to the administrative part. But if I am in a watershed, okay, then I will go also to the frameworks that are related to the watershed. So every time, setting your objective is the first thing that you do, and based on it, we have a very diverse choice of tools. Then you choose the one that is the most suitable for you. And here again, so as I said, the conclusion of today is what is the difference between the water accounting and the water balance. And so, as I said, the water accounting is part of the water balance is the part of the water accounting, and this is mainly what you should take from today, in addition, of course, to some tools that you might also go and browse. And as I said, there are also examples and frameworks and tools. So people have already developed a lot of tools, and it's now up to us to use them. Okay. So, for example, in TH Köln, we from time to time provide trainings within some projects for example, the water accounting plus framework, and we sometimes develop our own water accounting framework, such as the urban water accounting that we developed it for the city of Sarıkamış. So this is the first one. So the SIA-W or SIA Water, System of Environmental Economic Accounting of Water. This is a framework that was developed by the UN. It is generally used for the when we talk about policy framing. So it's generally related to the country level. And the second one is the Water Accounting Plus. So this is a framework that is developed jointly by IHE Delft and IMI. So IHE Delft, the university in the Netherlands, and IMI, the International Water Management Institute. And mainly it aims to use open source data, remote sensing, and QGIS. So everything that is open data to make your water accounting by generating 4 sheets. Okay, so the first one is the resource-based sheet, and you can see that like it shows you how much you have in, how much it is used in your system, and how much it is out. Okay, and for that it categorizes the water use into according to the land use, land cover, and according also to evapotranspiration. So this is one sheet. The second one is evapotranspiration, because in this framework they categorize between useful evapotranspiration and non-useful evapotranspiration. And here also I have very question. So a very simple question. What do you think this is the difference between useful or useful evapotranspiration and non-useful evapotranspiration. I can give you a hint, and this is related to the irrigation, right? And it is related to the agricultural sector. So generally, when we apply water or we irrigate, so if the water, we use it to grow crops, this is useful, right? So we didn't use this water. Now, this water that we applied, or this water that was fallen from precipitation, has been used to grow crops, okay? So this is what they mean by useful evapotranspiration. However, when we have like water evaporating from bare soils, okay, so it's just like piece of soil. There is no precipitation, no irrigation, no crops, nothing, and then the water falls and then evaporates. Then it's non-useful. We didn't use this water before it evaporates. And then we have agricultural services sheets, and finally we have utilized flow sheets. And finally, I would like to present the urban water accounting tool that we developed within the framework of this project, or the polyurban project. And it is also, we developed it under the same with the same concept. So it's a simple Excel sheet that is mainly personalized, I would say, for the context of the Southeast Asia and mainly for the Indonesian context, where we wanted to enhance our understanding of the urban water cycle here, support the sustainable water management practices, and inform decision-making processes related to water resource efficiency and security. So it is a Excel file that contains 4 Excel sheets: water abstraction, the second one, water discharge, flow diagram, and performance indicators. And in addition to that, we developed a guideline of a step-by-step how to use this Excel sheet. So this is the concept of the tool, and also I provided here a link. It is available online, and it is also part of our toolkit report. You can gladly just browse it and use it even. And we applied it for the study case of Sarih Harjo. And for the main steps, so the first one is we define and delineate our study area, or the areas or the boundaries of our study area. And then the second step is that we need to first understand the system, how much they supply or how they supply water, or how it is the supply of water done by the PDM, or it is like individual, or it is like individual, or they do it or they also supply water using like rainwater harvesting. So what we need to understand the system. Same for the wastewater, the stormwater. What are the different uses? And then we move to the data collection part, and finally we did our input. It's not working. Yeah, maybe. Yeah, okay. And then data entry and calculation. And of course, at the end, so we get this flow. So this is the third sheet, which is the flow sheet, and it shows to us how much water flows from the environment to the economy. The economy, we mean by it water supply, wastewater, the industry, the commercials, etc. How much water flows within the system, and how much water does go from the economy to the environment. And of course, using mainly Excel. So these are our 4 sheets. And for the data, thank you so much, Ms. Leni. You were such a great help to collect all the data about Sarih Harjo. In addition to the support of Ms. Leni, we also used reports that were available that gave us information to understand the system, either on local level, very local level, based on the baseline and the vision building reports from polyurban waters, but at the same time, Sleman Regency level reports. And we did our calculation. We tried to understand the system, how water is abstracted. Of course, I don't have much time to go into all the details, but at the end, we try to go step by step in understanding the system. For example, in the case of Stari Haujo, we have 3 types of drinking water supply. We have the PDM, we have the PAMDUS, and we have the also the individual supply using wells. And based on that, so we calculated the total volume. And so here I give a lot of details. Of course, Ms. Lenny can share with you the presentation and you can go through it. All how we did the calculations, how we estimated each type of the components of our study area. We also take into account and computed the water that was purchased by the local community. And same for the wastewater management. So we have either community-based wastewater treatment plants, or we have individual wastewater treatment using the septic tanks. So also here we took it into account. Also, we needed to assess, of course, precipitation. We needed to assess also the stormwater drainage, how much stormwater do we produce in our study area. So I don't want to go into very deep details. So this is also the step how we calculated the different components. And finally, as I said, we have performance indicators. After we calculated, we need to know, is our system okay? It is not okay, etc. So for that, we used several indicators, and for that, maybe the first one, we have the population and the water use intensity. So it's the intensity of the water use, and that's you have it like 0.44. So minimum water retention or loss within the system. We have 99.8 of the overall balance of inputs and outputs. So the when we compare inputs and outputs, so it means that like most of the input is used. Okay, and then we have the water supply. So we see that 8% are relying on centralized systems, while the majority are relying on individual systems. And finally, same for wastewater. Same again for the wastewater use. So I hope that I was on time, and I hope that you benefit something from this presentation, some tools that you might use in your studies. It was my great pleasure to be here with you to present it. And after Jessica's presentation, we can go through if you have questions.
All right, thank you so much, Chahinaz, for the presentation. Actually, as far as I know, in Indonesia, we make a water budgeting for national sectoral, but for the water accounting, I think it's still in a least level of the implementation. All right, thank you, Chahinaz, for the presentation. All right, next, we move to the second presenter, Xhesika Hoxha. She will talk about co-designing nature-based solution for Southeast Asia. Just quick remember, please continue to write down what you want to ask for Chahinaz or maybe to Xhesika. And all right, Xhesika, we are ready for you. It's still the same. Your presentation is 45 minutes. The floor is yours.
Thank you very much. Good morning, everyone. Louder, I cannot hear you. I cannot hear you. Good morning. Yeah. That's the energy that we need for today. My name is Xhesika Hoxha. I'm a research associate at the University of Applied Science in Köln. I'm working together with Chahinaz in Polyurban Waters projects, and I'm very happy to be here in front of you today, to be honest. It's my first time at the Department of Environment, and thank you very much for the invitation, Lenny, and organizing this. Thank you to the students for coming so early, waking up, and being here. Also, it's Ramadan month, And I would like to go through the content of my presentation. So in the beginning, we'll have a presentation about the concept of nature-based solutions, and then we will go through the introduction of the compendium of nature-based solutions for water resources management with a focus in Southeast Asia. Afterwards, I will present you a case study that we worked on during the potable water project in another case study in Laos to bring you a little bit out of here. And the next, it will be followed by another tool that we have developed in polyurban waters, and it's called Selection and Assessment of Potential Nature-Based Solution, and close it up with some recommendations. I want you to be a little bit more active. I really don't like that I'm here I would really like to be close to you. Yeah, I can maybe go also there. I don't mind. Because I want to ask you, did any of you heard before about the concept of nature-based solutions? I think you have heard. It's very trendy right now. Yes, please.
Okay. I would like to explain about this concept. So, as far as I know, nature-based solution is how we solve a problem by the solving that revert to the nature. The example like we have a problem in runoff or like that. So we make the solution by making some infiltration well or green roof to infiltrate our water.
Yes.
Thank you.
Excellent. 10 points. Thank you. Anyone else to add? No? Yes? Okay. I will also request all of you to put down your phones. Thank you. Put down your phones. Otherwise, I will come directly with a very quick questions. Okay? Okay. Then, of course, Chahinaz was talking about water balance, water accounting. We know the system, how it is going, like rainfall, precipitation, runoff, infiltration, and so on. And of course, in order to tackle these challenges, we want to give space to our cities in order for the infiltration to happen. So these the leftover, let's say, in the water balance, it's minimized as much as possible. So it doesn't go as a runoff in our streets or our system. But before jumping to that, I would also like to say that managing urban waters, it's a very complex process. And of course, the aim of our work is to ensure water security for the citizens, to have all people have access to water supply, to drinking water and also wastewater in a very good quality, available for everyone everywhere, and also in a constant manner. So the stability of it. But in order to achieve this, we have also other indicated or like other impacts from other outside resources. There can be social economic problems, climate change, of course, we know sea level rise, droughts and floodings, but also the governance part is one of the big points of it. I cannot. Yeah, okay. So what are our cities facing today is that we have a very big, it is projected that the urban population will grow almost will be tripled in 2050 in comparison to what we had until now. And by 2050, 70% of the population will live in the cities, and mainly 90%, 95% of the urban growth will be in the continents of Africa and Asia. Saying so, we looked at the Asian. If we look here at the secondary and tertiary cities, they will be overwhelmed. Mainly, especially, they are the ones who have or like hold the main activities of the citizens or the humans. This saying so, all the challenges that we are facing right now in relation to water, to water resources, is that we are having rapid urbanization in all the cities, which brings us to the point that the greenhouse gases are also increasing, and also many cities are facing the weak urban planning that cannot provide enough housing and meet the requirements for safe water and sanitation needs. Of course, this leads to large unmet infrastructure needs and strained resources with an impact in environment. Therefore, facing all these challenges, the concept of water-sensitive planning emerged. And the idea for that is that why do we need a water-sensitive city? Because we need a resilient, livable, and sustainable area to live in and to develop our life. But how can we achieve it? Of course, we want cities as water supply catchments. So the infiltration happens, the runoff is low, and it's also less in quantity. We want cities to provide benefits and healthy environment for everyone. And of course, cities that have communities that understand it and are willing to make wise choices about the water. Okay. But how is it linked? So, you also saw that in the presentation of Chahinaz. The natural water cycle, perfect here. In the first image, we have precipitation, infiltration, runoff, evapotranspiration. What we have done to the cities is that we have precipitation, we have built up, we have sealed as much as we could, and then we have large volumes of poor quality of runoff, reduced infiltration, we have discharged most of our wastewater into the rivers, into the creeks, and so on. And what we want to achieve is a combination of these two, because of course we cannot deseal everything, we cannot remove all the infrastructure, but at least try our best to increase the level of green areas, or to give the space to retention areas where the water can infiltrate. Therefore, the water-sensitive urban design water balance would be that we provide the space for the precipitation, more to for the runoff to go and to increase the infiltration of it, to recharge our groundwaters and have less water in the rivers, or to decrease also the flooding or flash floods in the streets. To make it possible, this concept in our secondary and tertiaries, or in our cities, the concept of nature-based solution evolved. What is it? As you mentioned before, it's there are solution or approaches based in nature. They aim to protect the existing ecosystems, conserve what is there, restore the damaged one, and sustainably use the existing ecosystem. In difference from what gray infrastructure, for example, provides, the solution based in nature, they address social, economic, and environmental challenges to provide human well-being with goods and benefits. And as I mentioned here, it's like an umbrella concept where you find strategic dimensions, spatial planning dimensions like green-blue infrastructure, green infrastructure, blue, and so on, soft engineering dimension, and performance dimension. And it is not a new concept. This is only the name to make it trendy, as I said before. it has existed before in different ways, in different words. And from our research, we found out that ecological engineering would be the first point where it's like, okay, in 1960s, at least there were integration of nature in all the infrastructure provided to the cities. And then it evolved to green infrastructure. And in early 2000, the MBS term emerged. So 26 years before. I was very small back then. And then it evolved when we reach here, when the MBS definition by IUCN was provided, the one that I also used in my first slide, until 2020, where the IUCN created a global standard to use for everyone around the world to kind of like bring everyone into the same level, to use the same tools and for the decision making. However, the implementation of these projects face a lot of challenges because of spatial requirements, like creating competition for land use, governance, because frameworks often fail to handle new challenges, which are very complex, the valuation of policymakers, usually, because they often favor gray over green, because of course you see the results easier than or like in a short term, and with MBSs you see the results or the effectiveness of it in a longer one. The finances, due to knowledge gaps in nature-related finances, because the way that these kind of infrastructure these kind of solutions are financed are a little bit more complicated than the usual gray infrastructure, and that kind of knowledge is not in every decision maker. So not everyone has that kind of knowledge to do that. And of course, people fail to respect what is non-human. But how do we design the MBS? We need to think, okay, we need to understand the system, the urban one, by involving actors and constituents, structures, processes, and the linkages between them. We understand and we assess the physical and built system, social and economic system, and also ecological system. This system, we try to find the interlinkages between them and among. However, the system that we are working with is interconnected with other systems around it. So if I have a city, if I'm working with the city of Yogyakarta, or I will take the Regency of Yogyakarta, let's say. Okay. And if I want to understand its complexity within the system, then I also have to go one step further and understand its interconnection with the next system, which would be Sleman, for example, or other connecting ones. And then in relation to the national ones, and maybe a comparison with an international one. But in order to find the solution, we understood the system, all the interlinkages. They are also presented here. The technological part is also added. We, together with multi-stakeholders, design and plan the implementation of MBSs because we need to have like a framework that directs our work to apply it in urban ecosystem as a holistic framework to describe the dimension involved in the urban environment. Going through that all work, we came up with one of our tools, and we have the title of it is the Compendium of Nature-Based Solutions for Water Resources Management, and it is a collection of 36 tailored MBSs for Southeast Asia's needs and demand. It has fact sheets with important information for each of the solutions, and also based on the challenges, benefits, and scales. And of course, it has a ranking system. You can be able to download the tool in the link that is provided here. What are the challenges addressed in our compendium? Water shortage, low quality of water, flood hazards, air pollution, food insecurity, tourism problems, and unemployment. But because of the scale and all the elements that we had to take into consideration is that we have the scale of action in a household, building level, parking spaces, garden, and river courses. For all of the 36 solutions, we also provided the similarity matrices for each of them. The first one is the ecosystem service similarity matrix. So how similar are each of these solutions in comparison to each other? Do they provide the same benefits to the human and non-humans or not? So in case that I would choose one urban park, I would see that, okay, urban park provides the same ecosystem services as the, renaturation. No, this cannot be true. I cannot read it, I'm sorry. But you can see that like this is another solution as the green urban parks. The same goes, you have the same similarity matrix with the address challenge that was mentioned before. So they are compared with each other if they provide or like if they tackle the same challenge or not. And in comparison to the scale of action, can you apply it in the building scale, in the river course, or in multiple of them? The fact sheets from the booklet, they have two sides, the visual profile, we call it, and also the descriptive profile. In the visual profile, you have one example of the solution. We have performance assessment graph and also implementation assessment graph, where we have scalability of it to which scale it can be implemented, maintenance, budget, and for the performance part, we have the effective time of implementing it, ecosystem services that they provide, and so on. In the descriptive profile, you have there shown the address challenges for the of the MPS, the action type and the scale, a graphic, and all the information that goes here is in relation to the installation and implementation requirements, ecosystem services, maintenance, and benefits that they provide. Together with the fact sheets, to make it more playable, gameful, we also provided a set of cards which can be used. They are in a small size. They have the same information as the fact sheets, but it's more it's more synthesized because they are used to be or like they are planned to be used in teaching environments, workshop with stakeholders, and so on. I have shown here some examples of the fact sheets that we also have in the booklet. For the building level, here is a rooftop rainwater harvesting. This is an example from Thailand, where the clay pots were used as the storage water that was collected from the rooftop. You can see the connection here from the household rooftop, and sometimes they would also open the part of the pots, and they would also have lilies there growing. Can someone tell me a solution that is based in nature for a building scale that you have heard of? Building scale. What can you, yes.
For building scale, I think it can be green walls, green rooftops. It can also be the design of the building that makes the air comes in easier, so you demand less air conditioning. Yeah, maybe that's it.
Excellent. I have nothing to add. We vote 10 points for her as well. Yeah, green roofs is another example in our booklet. In the neighborhood level, this is an example in Indonesia, where you have the infiltration trenches and you also have the gravel around it. A very simple one. It's not a very complicated structure, but a very simple one that can be used in secondary, tertiary cities. The same information goes also for infiltration trenches. For the neighborhoods, in our neighborhood, what can we implement else except of the neighborhoods? Okay, complete. No one has an idea? So if we are a group of people living in the same area, we have different houses, one street connects us together. What can we do? Or what can we propose to our government? Yes.
I want to verification question first. Is it for our neighborhood, right? Yes. The NBS. So I think for small scale we can infiltration well, recharge well, or maybe like in the what is it, technique, the engineering faculty, we have a lot of rain gardens. If you see, and there's storage pond, bioretention maybe, bioswale, but not much in here.
Excellent. We have ready all the experts, Lene. I should have been sitting there and listening to all the examples that you have. Yeah, we can build that in the neighborhood scale, of course. Green paths for cycling could also be one option. And the city scale, so these are all solutions that you can implement in larger areas. Green permeable paving system is one of them, where you have patches of concrete and also the green grass inside of it. And of course, this was it was during the dry season when I was here. So you can see that some of the patches are like completely dried and not filled with green, but you can see it a little bit more in the side here. That structure. What we can also build in a city, a project that can be implemented in a city scale, bigger than a neighborhood. Think big. What can we do there? City scale. Yeah, I think I have someone there who wanted to answer. Oh, no. Oh. Yeah, perfect. Yeah.
Okay. So for a city level, maybe we can move it to like open green areas like parks or maybe like playgrounds. So and then use it for the pavements and maybe for the sidewalks near the park.
Excellent. Good job. Yes, we both. Yeah, in the city scale, urban parks can be one of the solutions. And the basin level or like the watershed level, we can implement renaturation or revegetation of the riparian zones along the river. Can be one of the solution because it involves more than one city, and it is in a more bigger scale, and it takes the river course as their main scale. Can someone tell me another solution for that kind of scale? Watershed, river basin, however you want to call it. Keep in mind, we said these are solutions that can protect, restore, better manage the system. No? No one? I think we can discuss together. We can also discuss together, yeah? Okay. Don't worry. No one is wrong.
Okay. Does mangrove planting counts?
Which one, sorry?
Mangrove planting.
Mangrove planting. Yeah, in the delta part of the river. Yeah. Mm-hmm.
Um, I think that's all I know. I know something. It's called. I don't know what it's called, but it has the word barrier in it.
Barrier.
Um,
Where do you implement that measure, if you remember?
I think it's before the water bodies, and then you have like it's something like the ones in the picture, but then in the green areas you put like trees that um it somehow works like mangrove planting, but I don't think you plant mangroves on it.
Okay.
I just don't know the name. I forgot. I knew the name, but I forgot.
Okay.
So, sorry.
Sorry, I can also not relate to which one is it.
To search.
Okay, let me know. But
Yeah.
mangrove planting, excellent idea as well, especially in the downstream, completely in the delta part of the rivers. Works very well to stabilize the wave um, in strength. Ah, riparian areas around. Yeah. Okay. Yes, I understand. Yeah. Okay. Then it's the riparian areas along the river. Okay. Perfect. Indonesia has a great example for smaller ones. These are fish ponds along the river. They are not built in the whole section of the river, but only on the side of it, where water slows down a little bit, and also you can find their fishes growing and so on. While the water slows down, it also improves the quality of water because all the decomposition that happens in the water there. One other example, if I have there, or maybe not, I'm not sure. I'll bring you to the case study of Laos, where we were asked from the local government to develop a multifunctional water-sensitive park in Samnewa. I'm afraid that it will go very fast afterwards. So our team was requested to do that, and we first what we said, okay, let's point out where it is in the watershed level, and let's point out what are the main challenges there. So we have here the in one of them we have like steep topography. We have especially the red part, you can see it here, loss of primary forest, which is the dark blue color, and we have delicate channel structure. This park is this area here, where we have tried to show it with some picture how it looks like, and we tried to do the of course the mapping of the challenges here, and we have lack of riparian vegetation in these meandering parts and along the river. We have erosion river banks, as well as erosion landslides are these patches here, and solid waste disposal and flood hazard map, which are the patches with this kind of half transparency blue, let's say. After the challenges were mapped and also validated with our local stakeholders and other project team members, we went and this should have come first, but yeah, why not? So as for your reference, this part here is this bridge, and the area here is that area. No, this picture is in this side here. I don't know what happened there with the slides, but yeah, when saving maybe. After we had like 3 multi-stakeholders workshops and practitioners' expertise, international ones and local ones, involved with the academic input. We are an academic partner, so we reached out to the point of a proposed multi-purpose water-sensitive park where the riparian buffer zones were proposed to 10 meters in each side to be planted, and also walking path line for the trees. Here you have the path, and along it, the path needs to be also material of wood material, because all this area, as we saw before, it gets flooded very often. And we proposed, of course, the rooftop rainwater harvesting system in the buildings. These buildings here are public ones. The municipality offices were placed also here. And what else? Permeable surfaces, especially in the parking slot in front of the buildings. What is interesting, a retention pond here for the water during the rainy season and floods events. So the water can be stuck here and create the retention pond, while next to it, it can be a stilted a recreational area for the citizens of Samnewa city. After we developed all these cards and fact sheets for all the solutions in our booklet, we also said, okay, how to make it easier for our stakeholders from municipality level or for the regency level to make the selection and assessment of them easier, so they don't have to go through all the process of what academia would do. Yeah, we were requested with a tool, and we said we can provide it just for like a quick assessment. This could be the options that we can propose. This is an Excel-based tool where you can select in directional levels and to navigate through different scenarios while using different options. And of course, one of the this tool can also be, we have provided the link for download. You can use it. It's super easy. Okay. So this is MBSs from based, like the selection of MBSs based on the challenge mapping. In the first scenario, we have the we are based on the scale where, okay, you see here we are looking for a green solution on a building scale, because I'm working with a building. And the tool directly gives you an overview which can be the solution that can be in this can be implemented in this scale and are considered as green solutions. And you can do the same thing, but selecting more scales. For example, if you're working in a city level, but you also need some solution for the building scale and so on, you can end up, okay, this is one solution that you can implement in these two scales that you're considering. The same one goes also for the challenge. So I have challenges related to environmental issues. And so the sub-challenges that we have considered in the booklet as well are the soil erosion, water quality, and water storage. And after I have selected one of the sub-challenges that I want to work with, we can go, or like the tool proposes which can be the solutions to be implemented for the to tackle this challenge. The same happens if you have the economic challenges, and it will provide you with the solution. How it is based on the challenges, you can see it here. All of the measures that we have proposed, they have their own MBS type, green, blue, green, and so on. The type of action, restoring or managing. And here are all the challenges. The one that are green, the dots that are green, they show that this solution can tackle this challenge. And the one with red, it doesn't. Selection of the type, the same concept is applied, where we have here also the scale of action and the scalability of it. What you can also find in the tool is that you can have there a dashboard, let's say, where for each of the solutions you can find the graphs that we had in the fact sheets, the performance assessment and also implementation assessment. You can have graphs with like comparing different solutions between each other. If you're debating with yourself which one should I go, and you have like indicators like, I don't know, budget for you is very crucial. You have little budget. Okay, then I see that this embarkment mat will cost me more than plenty channel and reels. Yeah. But you can also use the dashboard as only to see one solution. You can also use more than two. You can compare more than two. I'll go to the recommendation part because we come to the end of our presentation. It is very important to increase the knowledge and the technical capacities of the stakeholders, including academia, students, lecturers, and everyone, but also local government, national government, to foster the implementation of nature-based solution. It is very important to address the challenges of especially institutional and policy barriers to overcome these challenges of implementing the solutions. We need to explore the institutional and policy framework on how to implement this better. Of course, it's super important for these solutions that communities are involved, engaged there, because these are the ones who are going to live in the future with these solutions. Ensure that local practitioners and municipalities are involved in the process with community, and localize relevant policies and planning strategies that support the implementation of co-developed concept, investigate innovative financial mechanism and partnerships that fund these projects. We mentioned before that the finance part is very difficult for the implementation of these measures. It is very crucial to investigate further this. Of course, managing and addressing the challenges of urban water resources, as also Shaina has mentioned before, is a very complex process, not only, which absolutely requires the integration of all the perspective of different stakeholders, of different sectors, and educational background, but also environmental factors. I will come to the end of my presentation, and I would like to present here. This is a toolkit that we developed in the end of the last phase of polyurban waters. It's called Water Sensitive Infrastructure Development, and it's mainly with the focus on Southeast Asia. All the tools that we have developed, also the ones that Chahinaz has developed, they are all there to give you a quick guide step by step through the tools. We request you to download it and try to use the tools because they are very handy, especially for environmental students. I would say crucial. So yeah, thank you very much. Terima kasih.
All right, thank you very much, Xhesika, for showing us about the nature-based solution for water sensitivity issue that we could solve that for the livable, resilient, and sustainable city. And maybe I would ask about, is the presentation could be shared to the students?
Yes, please.
Okay.
Both our presentations can be
Alright.
shared.
We will share it later. Next, we move to the Q&A session. For the student that want to ask for Chahinaz or maybe to Xhesika, is raise your hand. Okay.
Okay, I would firstly would like to say good morning to you both. This question is actually catered towards Ms. Chahinaz. So with how vast and rapid the world's changing, from social to cultural, and even my professor once said that water is political. So things aren't really that simple anymore now. So my question is, how can we make sure that the equation for water accounting and water balance can adapt to that change? And what method would you do differently for cases like this? Thank you.
Thank you. Yeah, very interesting question. Um, I would like to mention that, for example, in this case, when things gets more complicated, as I said in the beginning, that like generally we do not use only water balance, but we go into more detail and we go to the accounting. Okay, but still, the accounting should sometimes, like one framework, cannot 100% cover all the specificities of a specific study case, and that's why, for example. When we talk about the urban water accounting that was developed for the study case of Sariharjo, it is the same idea of many existing urban water accounting schemes that exist online. But we saw the relevance of developing one that is contextualized for the context of Southeast Asia, more specifically of Sariharjo. So generally, it is advisable that like when we are managing a system, either a watershed or an urban area, it is very advisable that we develop somehow the urban or the water accounting scheme of that area. And however, there are still some of the frameworks that takes into account all what you have said. For example, when we talk about the water accounting plus that was developed by IMI and AHE Delft. So this framework takes into account also when we have a watershed that is like, for example, transboundary, or a watershed that has like some treaties of importing water or exporting water to some other study areas. So they also take it into account into their sheets and into their equations. So it is in conclusion to your question, so first, it is advisable that when we are managing a specific system, it is very good that we adapt the existing systems to ours, or we create one based on what is existing. And second, some of the existing frameworks already take into account these kind of political or specific the specificities of this study area, and we can somehow just like include it based on what we have. Thank you.
Anyone want to ask to Chahinaz or maybe Xhesika? Okay.
Okay, so first of all, I would like the presentation is very useful, and I actually had a lot of insights from both of the presentations. And so I have a question for Xhesika. So knowledge gaps has been a barrier for nature-based solutions. So my question is there any effective methods to actually bridge the gap, and so the engineers and the stakeholders have the same knowledge, and then so for the maintenance it's actually more effective? Thank you.
Yeah, excellent question. We have to keep in mind that we are talking about two very different stakeholders, community and the engineers, right? So, of course, the level of knowledge that comes from an engineer is very specific and detailed, and of course, all the information that or like all the knowledge that they have. To translate that to the citizens, it requires a level of knowing the solution so good. So when you speak to the citizens, it's the easiest way of transferring the knowledge. In academia, we talk a lot about knowledge transfer. So we read papers and we have to translate them into a very understandable way, all the concepts for the students, for example. No? The same needs to happen also between the engineers who are involved in the projects of nature-based solution and the citizens. And there are different methods or approaches that you can do that. Of course, what we know right now is awareness raising for these solutions and campaigns about telling them how you can build them if it's a small scale, but also the same thing needs to happen also for the maintenance of these solutions. We have also tried different approaches, especially here in Sariharjo with Prast from Aksansi. We provided some trainings in their office, for example, and where we show some cases, like some small MPSs that they have in their office, and the training of all the different stakeholders happened there in the open area next to the rice fields. And it was very effective because afterwards we could see that Department of Environment was very interested to implement some of the rooftop rainwater harvesting systems. Citizens did some changes in an area near the grave area. Yeah, okay. So yeah, like you need to try different ways of how to translate this information to citizens, so they all have the same understanding. Thank you.
Okay, next who want to ask? Please say your name and maybe your year of study.
Okay, I would like to ask some question. And firstly, let me introduce. My name is Lina. It's my nickname. So I was the third year of environmental infrastructure engineering. So my question was to, I guess, I will to Miss Jessica about your presentation of the tools for assessing the solution and the methods. So I would like to ask, does the assessment we do manually or it is done automatically by the system? And if it is done automatically with the system, what data do we input? And also, in what aspects does the solution taken? Like, is it also depend on social, economic, or maybe governance? Because I guess the NBS challenge in our era is economic, social, and something like that. So that's all.
Thank you very much. I will go back to either my presentation in the last slides. I knew someone would ask about it. So if you go to the, thanks. If you go to the compendium, we don't have it here. Can you please go to my presentation in the last two slides? Go after this one? After. I had it as a backup plan. This one. Okay. So how did we do the performance is based on the performance assessment. Wait, let me. Ouch. We have here, we decided together with our stakeholders in the region of Indonesia, Cambodia, Laos, Thailand, and Vietnam. We said, okay, we want to go with ecosystem services, effective time, versatility, morphism, type of action, ecosystem service morphism. And we said, okay, what we explained or described all these indicators that we used, and we also used a scale for it. And we asked some of our local experts to evaluate each of the solutions with numbers and a scale. For the implementation assessment, we used the metric was based on the maintenance, how much it requires to be implemented, the budget, implementation time, scalability, morphism, and scalability. These were the ones that we were trying to put in the assessment graphs. And of course, when we built the Excel-based tool, we said that, okay, we want to create it to be easy for everyone to use. So you have all the information there and you don't have to calculate it yourself. Okay. The follow-up question was the data input, that if we want to use it, like if you need to put this kind of data. No, this is calculated based on experts' evaluation, and also each part of this has different weights because budget, for example, is more important than maintenance and so on. So it was just like that assessed.
Okay, maybe thank you for the answer. It actually already answered all my questions. Thank you very much.
Thank you very much.
All right, anyone want to ask Xhesika or maybe Chahinaz? Okay. Arlanda.
Good morning. I am Arlanda, an undergraduate third-year student in environmental infrastructure engineering. Actually, I am asking about because I'm curious about. We're talking about Southeast Asia as majority, but maybe because in Southeast Asia, especially Indonesia, we tend to adapt technology from like other countries like Europe, America, or something like that. So I will ask about how was the integrated water resource management in Germany, I guess, or in Morocco, in your country. Because maybe from your perspective, from the other country's perspective, this is important. But maybe when you see it in Indonesia, in Southeast Asia, it's not being assessed as an important aspect, or maybe there's a gap and miss in that. Maybe in that. Thank you.
So, if I have well understood your question, so you mean like how integrated water resources management is implemented in other contexts, such as Germany or, for example, Morocco, right? Of course, what's different mainly, or the starting point that would, of course, create the difference is that the challenges might be similar or might be different, okay? And also the context of the study area, okay? So when we talk about Indonesia or Southeast Asia, when we talk about the huge amount of precipitation we have, it's not like when we talk about Germany, and it's not the same when we talk about Morocco with the Mediterranean or desertic sometimes climates, okay? So this is the first input point. And second, also, it's the, as I said and as I mentioned, is the challenges, okay? So here we are mainly focused on peri-urban areas, but for example, when we go to the context of Germany, it is more urbanized, and also the solutions also that can we suggest, sometimes they are applicable in the context of Southeast Asia, because for example, we have a lot of precipitation, so it's meaningful to put, for example, green roofs with specific vegetation. But when we go to Morocco and we don't have much precipitation and a lot of precipitation, so it doesn't make sense to put specific, for example, if we would like to implement green roofs, to put some plants that are not resistant to droughts. Okay, so I think that when we change the location, so IWRM stays the same, integrated water resources management, including all the stakeholders to achieve a better and sustainable management of the water resources, to achieve the economic welfare, the social welfare, and sustainability of resources. But the difference is in the system. Okay, what is my system? How it is behaving? What are my main challenges? And also the solutions that are adapted to my specific context. So yeah, that's it.
In regard to the solutions, I would like to go back to how Lenny started the presentation or like the session today, where, of course, for the solutions, for nature-based solutions, it's not that we created them in 1960s. Huh? It is about the knowledge before that, our actual knowledge. And when we talk about it, is that if I want to propose a nature-based solution in the context of Sarihard or Germany or whatever, I would always have to go back to what was applied before, in what is the local knowledge. Like we should not, and I say we should not allow the maladaptation of these measures in our cities, in our countries, which means that I have seen a lot of projects that have been just copy paste from New York or I don't know, in the context of Southeast Asia. Total nonsense, because of course here is a different climate. The people are also acting differently in an urban park, for example. In Germany, everyone sits in the urban park without like any question. In New York, you cannot. There are fences and you can walk around them, but never go and sit in the middle of a grass area. So also in the social aspect, but environmental and economic aspect, we have to localize the solutions. We have to bring back the local knowledge and for the to not go into the maladaptation of measures.
Thank you very much.
All right, is there any question from student or maybe the others? Okay.
Okay, so my name is Amanda. I am also from third year of environmental infrastructure engineering. I'd like to ask um, if nature-based solution were to be implemented in areas with people that are less exposed to technologies and engineering's applications, and if it were to be implemented there, but let's say the project team would be in the area for like 50 days or 60 days, and to implement the project, how to maximize that after the project is built, the local community can take ownership of the long-term maintenance and the maintenance of the biological needs and everything, so that we can make sure the sustainability of the nature-based solution is applied. Thank you.
Thank you very much for your question. The title of my presentation was co-designing. So it starts from the beginning. If you were to plan an MBS project somewhere in an area, citizens should be involved from the initial idea of the project and not in the end of it where it's like, oh, we have decided this beautiful park to be built there and you have to take care of it right now. Citizens need to be involved from the beginning to design it, to be involved and heard what are their needs. For example, in an urban park, an example, how would they use the park? How often? What do they like to have in the park? Do they want to have a table or a chair? Do they want to have grass or trees more? I don't know. Like all these questions are about like we need to involve citizens from the beginning in order for them to understand through the process how it is built, why, and of course afterwards how they can maintain it. The maintenance requires supervision. Of course, it cannot just be led, oh, you have to do maintenance now, goodbye. Of course, the ownership can be there, but imagine in that area, for example, these people who took the ownership for the maintenance, they leave one day because they want to change the city. You know, all that process is gone wrong afterwards, and it has to be structured. It has to be put into the legal framework. So of course, it has to. The maintenance should anyway be at least supervised from the local government or agency government, and not just be left without any kind of supervision. Yeah, that would be my answer to it.
Thank you.
Thank you.
Next, is there any question? Be from Pak Nil, Bu Saras, or Bu Nurul, maybe? Or from the students? Or maybe last question? Is there anyone to ask? Or maybe it's enough for the question, this Q&A session. Thank you very much, Jessica, and also Chahinaz. Please have a seat. Okay, the next one is to be give the from our apartment to Jessica and also Chahinaz. From Miss Lenny. I think to the stage for okay, for all the audience, please go to the stage, Bu Lenny. Go. Okay, for the student, please go to the stage. And for the panel, Bu Saras, Bu Nurul, please go with us.
Silahkan.